Hello, this is Dr. B, topic 2.1 for AP Chemistry, types of chemical bonds. The objective is to be able to explain the relationship between the type of bonding and the properties of elements participating in a bond. So we're going to talk about electronegativity, we'll address Coulomb's law, valence electrons, and different types of bonds, different types of covalent bonds, etc. So we talked about electronegativity before. It is the measure of the ability of an atom or group of atoms to attract shared electrons. This can be explained by using Coulomb's law. The attractive force between charged particles increases with an increase in charge and decreases with an increase in the distance. Some of you were asking for a good explanation of what is Coulomb's law. That's it right. That's it right there. Electronegativity decreases as you move down a column as there's a greater distance from the nucleus and because there's also more electron shielding. Electronegativity increases as you move across a period on the periodic table, so left to right. This is because the atomic radius is decreasing while the number of protons and effective nuclear charge, therefore, is increasing. Fluorine is the most electronegative element. We've talked about that before. It has a small radius with a small amount of electron shielding coming from the 1s electrons to the effective, so therefore the effective nuclear charge is high. This results in a strong pull on shared electrons. When you compare the differences in electronegativity between two atoms, there are some cutoffs for what makes a polar bond, a nonpolar bond, and ionic. So there are two types of covalent bonds, nonpolar and polar. In a covalent bond, there's a sharing of electrons. However, if it is nonpolar, there's equal sharing. If it's a polar, it's unequal sharing. So remember that for something to be polar, it has to have something called supposed to have dipoles. That means that between two elements, like say two covalents, so let's say HCl, between the two, they're both nonmetals, so they're sharing electrons. However, chlorine is way more electronegative than hydrogen, so it's going to have a stronger pull on those electrons. So that means it has a negative dipole, and H has a positive dipole. So if there's a nonpolar covalent bond, there is a very small or no difference in electronegativity. If it's an ionic bond, electrons are not shared, they're transferred or stolen. Think about the tug of war from before. It talks about the bond dipole moments. Remember, you're forming ions. It's like a positive ion and a negative ion, something like that. Cations and anions. So for example, H and H, no difference in electrons. Electrons are shared equally, nonpolar covalent bond. HBr, slight difference in values. Electrons are shared unequally, polar covalent bond. Sodium chloride, large difference in values for electronegativity. Therefore, they're not shared, they're transferred or stolen, ionic bond. You can also determine if a substance is going to have ionic interactions based on, like we said before, metal and nonmetal, ionic attraction. So we're going to break down each of these briefly. So ionic interactions occur between metals and nonmetals where they lose or gain electrons to form ions. This type of attraction, this is good keywords here, Coulombic or electrostatic attraction. The ionic bonds are stronger when the charges are larger and the ions are smaller. This is explained by Coulomb's law. Properties of ionic substances: forming crystals, lattice of positive and negative ions. They have high melting and boiling points. They're hard, brittle, conduct electricity when dissolved in water and when molten, and good insulators as a solid. Metallic bonding occurs between metals. It can just be for one type of metal, a pure substance like gold or silver or something like that, or for different types of metal, a mixture called an alloy. We'll talk about alloys in the next topic, I'm sorry. The metallic attractions are due to multiple metallic cations being attracted to a delocalized sea of valence electrons. This phrasing right here is important. The IMF's intermolecular forces are stronger when there are metallic cations and when there are more valence electrons. So you have your ions, and you have a sea of free moving negative electrons. Properties of metallic substances are shiny luster, malleable, ductile. Malleable means bendable, ductile or ductile, I can never say that word, means you can put into wires. They conduct heat and electricity. Metallic oxides are basic and ionic, and they lose electrons to form cations. Nonpolar and polar covalent molecules, they tend to be non-lustrous and not shiny. Brittle, hard, or soft, just depends. They don't conduct well. Non-metallic oxides are acidic and covalent, and they form anions by gaining electrons. So the more right you go in the periodic table, and up, I guess, the more likely they're to exhibit non-metallic characteristics. Down and left, so we're going away from that, metallic characteristics. Place the following bonds in increasing order of polarity. So that means that we're going from least to most. So polarity means that if it has poles, if there is like differences in electronegativity. So the least ones are going to be the ones that are most likely non-metals. And the fact that you have one here where it's the same atom shared or bonded together, that's going to be the least polar. So that's that one. So we look for the next one. There's another pair. There's a lot of carbons that are going to be paired up with a non-metal, but the next one that we're going to put down is carbon and hydrogen because there's not much difference between the two. Next, we look at C and F and C and O. We know that F is the most electronegative element compared to the other ones, so it's going to be CO, CF, and then the last one, so polar that it's actually just ionic, so it's going to be Ca. C is the last one. Classify the substances below: nonpolar covalent, polar covalent, ionic, and metallic. So nonpolar covalent, there we go, H2, CH4. Let's kind of make it easier on us. So ionic is going to be NaF, because there's a metal, non-metal, zinc chloride. Metallic can be either single metals or some kind of alloy. The next two, or the next leftovers, because polar covalent, so the way that these are going to be bonded to each other, or not to each other, but like within each compound, if you will, or each molecule. Like, for example, this is H and H, CH4. The last two, there's no same elements. One is more electronegative than the other. There's some difference here. The way that N is drawn out, there's a polarity, so it's going to be it's going to be unbalanced. So it's going to be NCl3 and NO. All right, that's it for now. If you have any questions, please let me know. Thanks.